In the previous video, I derived that the change in entropy, which is related to the number of configurations, at a particular temperature and given a certain input of heat, which I am calling delta Q, that change in entropy is delta S is equal to delta Q over the temperature. The entropy is related to the number of configurations as Boltzmann's constant times the natural log of the number of configurations, and K here is 1.4 times 10 to the negative 23 joule per Kelvin, and those are the units. So we can figure out, kind of the change in the number of configurations when we do something as simple as heating up a glass of water. So let's say we have a glass of water that is around, say room temperature. And so room temperature is about, its temperature is about 294 Kelvin. We have to make sure that we do these calculations in Kelvin. If I warm it up by 10 degrees, I can figure out how many joules that'll take from the specific heat, 4,200 joules per kilogram degrees Celsius. And then times, let's say it's a glass of 1 liter, so 1 kilogram, and then we have the 10 degrees Celsius. This gives me about 42,000 joules. The change in entropy then, delta S, would be equal to this 42,000 joules over 294 Kelvin, about 143 joules per Kelvin. If I want to translate that to number of configurations, I have to set that equal to K, and this is again a change in the number of configurations. So this is really the logarithm of the kind of number final over the number initial, and you can kind of look at that later. So this is the quantity that I'll actually be able to find. K being 1.4 times 10 to the negative 23, I'm going to get that ratio, W final over W initial, is going to be on the order of 1 times 10 to the 25, all right, when I solve for that. Now, if I want to translate this to base 10, I can divide by 2.3, and this leads me to log base 10 of the change in the number of configurations final over initial, all right, is equal to 4.4 times 10 to the 24. So this ratio of like how many configurations I wind up with versus how many configurations I started with, and this is configurations of essentially the energy in the molecules bouncing around in this glass of water. I've raised it 10 degrees. Is going to be this, rather large number of 10 to the 4.4 times 10 to the 24. So we essentially have something that's 1 0 0 0 0 and there's 10 to the 24 zeros here. All right, and that's an enormous number, and that's just the number of configurations that we get when just raising a single glass of water by 10 degrees.